In this video, we're looking at the solutions to the practice test for differentiation and logarithms. Make sure that you have yourself a graphics calculator, your cheat sheet, so your A4 handwritten notes, and also the SACE formula sheet for methods. Although the only thing that will really be useful on here are these three rules: product rule, quotient rule, and chain rule. All right, you're being assessed on these performance standards. So do you know what you're doing? Can you do calculations? Notation, your communication, so that'll be first principles here, and among other things. And then can you do conjectures? So there will be some conjectures in here to look out for as well. All right, first thing to differentiate this. So dy dx, make sure we have the correct notation because it's y. So dy over dx, so that's going to be 3 times 5 out the front. 24x and drop the power by 1 squared, plus, and then the x will become 1 and the 15 goes away. This one here, you can actually rewrite the original function. Fractions split out nicely if you split the top apart, but not if you split the bottom apart. So you can write it like this. You can then apply your index laws. So you get 8/5 of x, take 3/5 of x cubed, and then f dash of x is going to be 8/5 take 9/5 of x squared. Now I'm fairly sure a lot of people wouldn't have done that because your intuition when you see this is probably just to use the quotient rule. So if you had to use the quotient rule, you would get this. So you'd get 32x cubed take 18x5. V is 5x cubed, so v dash should better be 15x squared. All right, if you use the quotient rule, you're going to get 32x cubed take 18x5 with 5x cubed, and then you v dash, so that's 8x4 take 3x to the 6 times 15x squared all over v squared. So that is 5x cubed all squared. Now both of these would have been considered correct, but the first method's going to be a lot quicker. One of the things that you're being assessed on is not only can you solve problems, but can you do them efficiently. So if you do stuff with slow methods, I'm not going to take marks off you, but you might run out of time in the test. It's specifically designed that way to make sure you're being efficient. Here we've got to use the chain rule. So you got a half 7x cubed plus 5. The new power is 1 less, so that's minus a half. We're going to times it by the baby, so that is 21x squared. All right, here you do have to use a product rule. So this is u is 2 root x take 4x to the 4. And just to help differentiate that, we'll write that as 2x to the half. V is going to be 5x cubed plus 2x squared. So u dash is going to be 2 times a half is 1. And then that's 16x cubed. V dash is going to be 15x squared plus 4x. So dy dx is u dash v plus u v dash. So that's going to be x to the minus a half take 16x cubed times by the v. So that's going to be 5x cubed plus 2x squared. And I'm going to run out of space in a second. Plus uv dash. So that's going to be 2 root x take 4x to the 4 times v dash. So that's 15x squared plus 4x. Obviously plan out your working before you do that so you don't have to do what I did there. This one here, the derivative is going to be, well, it stays as 2e to the 3x, but you times it by the 3, like the baby from up the top. So what you get is 6e to the 3x. This one here, you could use a quotient rule, but a much quicker way to do it is to rewrite this as 1 take e to the power of x squared minus 3. Then when you do the derivative here, you're going to get minus 3 out the front. Minus 4 is your new power. And then inside here, we need the derivative of that. So it's minus e to the power of x squared times by 2x. So that's the chain rule there. All right, log of x squared take 3. So the derivative is going to look like this. It's going to be x squared take 3 on the bottom, and it's going to be the derivative of that stuff on the top. Here, what you need to do is split apart the log first. So log of x cubed plus log of root 3 take 4x. And then you can even go one better and pull the powers out the front. So that is 3 log of x. The root would be a half, so pulling that out the front, I get a half log of 3 take 4x. Now that is still y. The y dx is going to be 3 lots of 1 over x plus a half lots of 3 take 4x on the bottom and minus 4 on the top. That's the derivative of that stuff on the top. I won't simplify it anymore, but you could simplify it a little bit if you wanted to. U here is 3x4 and v is log of x for the quotient rule. U dash, the product rule, sorry, 12x cubed, and v dash is 1 over x. So if I product rule this, I've got dy dx, u dash v plus uv dash, just there. That's going to be 12x cubed with log x plus 3x4 with 1 over x. Cos of x cubed plus 1. Cos goes down to minus sign. You never ever ever touch what's inside the brackets, and then you got to times it by the baby. So that is 3x squared. Now, since we started with y, this is dy dx. Don't forget that because you are being assessed on notation here. All right, sine of x over x, this is where we need to use the quotient rule. So u is sine of x and u dash is cos of x. V is x and v dash is 1. So dy dx, I'll just write out the quotient rule. That is u dash v take uv dash all over v squared. It's going to be cos of x times x take sine of x times 1 all over v squared. So that's x squared. Log of cos. So log differentiates like this. You've got the original thing on the bottom and you've got the derivative on the top. Not that you need to do this necessarily, but fun fact, that is minus tan of x. Interesting. All right, next we got this function here, so we want to show clearly the derivative. So now that we're showing clearly, and it's a show that question, you need to be really clear about which rules you're using. So this is going to be the quotient rule, and I will be saying that in little curly brackets. So f dash of x is u dash v take uv dash over v squared. Just clean that up a little bit, uv dash. And then this is the quotient rule. So since it's a show that question, please actually say what you're doing. This is going to be 3x squared is u dash, lots of x take 1, take x cubed times by 1. And it's going to be x take 1 squared on the bottom. This is going to be 3x cubed, take 3x squared, take x cubed. And this is going to be expanding. And then you can collect like terms. So 3x cubed take x cubed is 2x cubed. It's going to be like terms. And then what we'd like to do is factor x squared. So x squared comes out as a common factor. We're left with 2x take 3 on the top, and we're left with x take 1 squared on the bottom. All right, that's what we wanted. And then usually we write as required when we've done a show that question. For what values of x is the gradient of f of x flat? So this is going to be that the top of the fraction equals 0. So therefore, well, it really is that f dash of x equals 0, and that means that the top equals 0. So that's x squared and 2x take 3 equals 0. Now, if you get this here, that would give you x equals 0 because x squared equals 0. And then this one here would give you 2x take 3 equals 0. So that's 2x is 3, or x is 3 halves. Wonderful. So just restating out what you've got there, x is 0 or x is 3 halves. Now what we should do is we should actually graph this original function, x cubed over x take 1, and then we'll have a look at what's in there. So just to delete out any old stuff you've got in there, pop in a fraction. Yeah, I might as well do it in there. X cubed over x take 1. Graph that. There we go. You can see the tangent is flat at 0, and it's also flat at what appears to be 3/2. So just to check, if we trace 0, that'll highlight that point, and dydx is 0. And if we trace 1.5, then it should also have dydx is 0. Now, if you don't have the dydx showing on your calculator, I want you to go in here and turn derivative on, and that should do it. So that was just in Shift menu for setup. Notice that the graph doesn't exist at 1, so that's what we're expecting for the next answer. For what values is it undefined? So this is that the bottom equals 0. Therefore, we got x squared take 1 squared is 0. Sorry, that was just x take 1 squared. X take 1 is 0. Therefore, x is 1. Yeah, this next one here, explain why that is that. This is just purely the index laws. That's all I'm looking for there. Use product rule to show that that is true. So y is going to be a of x times b of x to the power of -1. And we're going to use the product rule. So dy dx is u dash v plus uv dash. U is going to be a of x. So u dash had better be a dash of x. V is going to be b of x to the power of -1. So v dash is going to be minus b of x to the power of -2 times b dash of x. All right, so this is u dash v, so that's going to be a dash of x times b of x to the power of -1. I'm just using the square brackets to make it a bit easier to see which brackets are which. They don't really mean anything. A of x is u, and then we're going to times that by v dash. So this could equal b dash of x over, well, negative, over b of x squared. So that is what we'll do. B dash of x over b of x squared. What I might also do is I might write this thing here as 1 over b of x, just like that. All right, so this is going to be a dash of x over b of x plus, and it's going to be a of x b dash of x over b of x all squared. We need to cross multiply, so really in particular I'm going to be timesing by b of x over b of x to get b of x squared on the bottom. So let's do that. So that is b of x times a dash of x plus a of x times b dash of x. So this is cross multiplication. And then here, since we're doing a proof, we should say product rule. All right. Then we can just rewrite it how they wanted. So they wanted the a dash first. And then the a first here as well. So this is going to be rearrange. And then this is as required. What rule did it disprove in B? It is actually the quotient rule that we just proved. Wonderful. U dash V, take U V dash over V squared. It's just we're using A's and B's rather than U's and V's. All right, next we have this function. So first thing we've got to do is calculate the second derivative. So this is going to be 2k coming out the front. Just like that. Because remember, any constant like 2k is going to, when you have 2kx, that'll differentiate down to 2k, and that comes out the front as the baby. There's plus 2x at the end. Then f dash dash of x, we're going to be bringing another 2k, so that's going to give us 4k squared plus 2. Therefore, f double dash of 0 equals 6, so we're going to get 6 there, and I'm going to be plugging in 0 for the x value, and we'll see what happens. So this is going to be 4k squared e to the 2k times 0 plus 2. So this is going to be 6 is 4k squared e to the 0 plus 2. So 6 is 4k squared plus 2. Therefore 4 is 4k squared. Therefore k squared is 1. Therefore k is plus or minus 1. Because when you take the square root, you got to do plus or minus. Done. All right, we got this log of x and log of 8x. So show that f dash equals g dash. F dash of x is 1 over x. G dash of x is 8 over 8x. And we'll cross off the top and the bottom. And what we're left with is 1 over x. Wonderful. There's the graphs, state the relationship. So g of x is log of 8x. Now we know the slopes are the same, so this can't be like a stretch of any kind because then the slopes would be different. So we can split this apart. So log of 8 plus log of x. And then this is g of x is log of 8 plus, and then this original thing was f of x. Therefore, g of x is a vertical translation of f of x up by log of 8 units. Suppose f of a equals 10, find g of a. Well, I mean, we literally just learnt that g of x is log of 8 plus f of x, and this is from b. Therefore, g of a is log of 8 plus f of a, which is log of 8 plus f of a is 10, so that's 10. So that is g of a. Now, I didn't ask for an exact value, so I might actually just leave it at that. I didn't ask for like an approximate or anything, so we're just going to have it as the exact value there. All right, we have this wonderful conjecture. For n equals 2, this function looks like this. Basically, the function's just going to be as many brackets as the n value is. So f2 of x is log of x plus 1, x plus 2. This you can split up into log of x plus 1 plus log of x plus 2. And this is the log laws. So that is still f2 of x. Therefore, f2 dash of x is going to be 1 over x plus 1 and 1 over x plus 2 as required. So there's some more functions. Develop a conjecture. So the conjecture should be let fn of x equal log of x plus 1, x plus 2, all the way up to, we're timesing these, x plus n. Then fn dash of x is 1 over x plus 1, 1 over x plus 2, all the way up to 1 over x plus n. For all n in z plus. Now z plus will be positive whole numbers. All right, preview conjecture. Fn of x is log of x plus 1, x plus 2, all the way up to x plus n. So this is log of x plus 1 plus log of x plus 2 plus all the way up to log of x plus n. This is from your log laws. So this is 1 over x plus 1, 1 over x plus 2, and 1 over x plus n. And we proved it. That is the derivative. All right, use first principles to find f dash of x here. Wonderful. So this should be on your cheat sheet. F dash of x is limit as h goes to 0, f of x plus h minus f of x all over h. Now, I can't stress enough that needs to be on your cheat sheet because it is not on the SACE formula sheet. All right, let's see what x plus h is. So this is limit as h goes to 0. This is 7 brackets x plus h squared plus 4 take 7x squared plus 4. Put that all in brackets, otherwise you're going to have an error. So that is limit as h goes to 0, 7. Now we can expand out this brackets, x squared plus 2xh plus h squared. Plus 4, take, now I'm just going to leave this bit in brackets now because we'll expand everything out in a second. All right, this is limit h goes to 0, 7x squared plus 14xh plus 7h squared plus 4, take 7x squared, take 4, all over h. This is limit as h goes to 0. The 7x squared and the 7x squared are going to cancel off, so they will cancel off with each other. You've also got the plus 4 and the minus 4 cancelling off with each other, so there and there. So this is 14xh plus 7h squared on the top, and it's h on the bottom. Now I really want to stress, we do want to have some notes, so expanding a plus b squared is a squared plus 2ab plus b squared. And let's see what else we need to put. Then this one is going to be more expanding. And this one's going to be cancel like terms. If you got time to do this, is a good idea, just because you're being assessed on communication and you want to, first principles are essentially a show that question. So limit as h goes to 0, h can come out, you're left with 14x plus 7h all over h. Now this is basically factor out h. And then h will cancel off the top and the bottom. So there it goes. So this is limit as h goes to 0, 14x plus 7h, which is 14x plus nothing. And you can just put h equals 0 here. So this is f dash of x. Wonderful. And that is what the derivative should be. All right. We got this one, which is a fraction first principle now. All right, so we'll start this out as we normally do. F dash of x is the limit as h goes to 0, f of x plus h. Take f of x all over h. Now this is going to be the limit as h goes to 0, 6 over 4 brackets x plus h, take 2. Take 6 over 4x, take 2, all over h. Yeah, this is going to be limit as h goes to 0. Now, what we need to do is cross multiply. So I might actually do this on a whole new line. 6 over 4 lots of x plus h, take 2, is there. We're timesing this one by 4x take 2 over 4x take 2. And then we're timesing the right one by 4x plus h take 2. Wonderful. So that's the trick. Since it's the first principles, well, I showed that question. We should probably explain any of the trickier steps we're doing, so cross multiplying. And then this should all still be over h. So this is limit as h goes to 0. It's going to be 6 lots of 4x take 2. Take 6 lots of 4 brackets x plus h take 2. Common denominator is 4x take 2 and 4 brackets x plus h take 2, and the h comes up with that as well. All right, now we can expand. So limit as h goes to 0, 24x take 12, take 6 into 4 lots of x plus h take 2. So I might actually leave this out the front as 6, and then we're going to call this 4x plus 4h take 2. We'll have to just do another step expanding that in. All right, next step, we're just going to expand out the top. So we're going to be left with 24x, take 12, take 24x, when that 6 expands in, 24h plus 12. All over h, 4x take 2, and 4x plus h take 2. All right, next. So this is going to be limit as h goes to 0. So 24x and 24x will cancel off on the top like that. So we'll do 12 and minus 12. So all we'll be left with is minus 24h all over h, 4x take 2, 4x plus h take 2. All right, now we can cancel the h's off the top and the bottom. So there they go. And we're going to be left with limit as h goes to 0, minus 24 all over 4x take 2, and 4 brackets x plus h take 2. Now at this point we can actually sub in h equals 0. So you'll get minus 24 over 4x take 2, and this other bracket will become 4x take 2. So just h equals 0 there. And then pretty much that just gives us minus 24 over 4x take 2 squared. And we're done. You can check this question using like the quotient rule, although that's more something if you have enough time to do it at like the end of the test.